I know I forgot to plug my mic in again. Hello, how you guys doing? Bridgewater Goes with Coding. Welcome, welcome. I knew I was forgetting something. It turned out that something was plugging my mic in. So, a little bit. But how you guys doing? Welcome, welcome. Mouse, how you doing? So I'm gonna try something a little different tonight. Last time we got some of like the wall stuff working or whatever. That's cool and all, but I wanna try something a little different tonight. I wanna see if I can get some an animated background going. I should turn on my alert sounds and things. So I made this about like a half an hour ago, if that, in over in GIMP over here. So what it is it's just a animated wave kind of looking thing. Oh, this is, how you doing? Welcome. Can I get like play and zoom? Let's go 200%. Yeah. So it's 15 frames of a little animation using a filter and an animation thing in GIMP. Haskell's confused. I don't know any Haskell, so I can't help you there. We're gonna try to set this as the background in the game. So we'll be replacing the black background with this. Will I keep this this specific animation for the end product? I don't know. Maybe. We'll see how it works. But I figured once I get the process down, I'd be able to change it a lot easier. Toolhound Software in New York. How you doing? Welcome, welcome. So yeah, so we're gonna try and get this in the ROM and animating. Now this is gonna be a little tough for one main reason. It's a lot of data. It's a lot of data. So if I open up this utility here, and let me actually, this one here. No, we're gonna do one and then a single. So a single frame of this is that many tiles. So it's a 64 by 64 pixel image, right? That's 4 rows of CHR. Now I cannot transfer that many in a single frame. Not without turning off the PPU a few scan lines before the end. I don't really want to do that. Yeah, it's big. It's big. It's actually about a K, about a single kilobyte. Because each this screen here is 4K, and that's 1/4 of the screen. Why not make it half the resolution? I could, but I want to see if I can get this working. Because the way to do this would be to kind of buffer it. So I have 2 pages really of CHR ROM, right? One that is typically used for like the background, one for the sprites or whatever. No, it's 4. But so I'm only like really using I'm only really using one of them, right? Where's my green screen screwing up? Come on, stop it. That's just gonna plug out, I guess. So I'm only really using like one of them, right? Do I have effectively done? So I'm just gonna be animating frames. So I'm just gonna take those frames as animation frames and then just feed them to CHR. So let's actually get into the game here real quick. Pause that. Actually, I don't even need to pause it. Just keep on going. Now I'm only using half of this CHR for everything right now. So I still have like half of it, almost half, a little less than half. So I'm using a little bit more than half for everything, but I have a little less than half to dedicate to the background, which is plenty. And if I duplicate them across the pattern tables, I could update one of them while the other's displayed, right? So it'll take let's say 4 frames. So that's not too bad. That's not too bad of animation, I don't think. If you're a demo senior, know how to do procedural animation on the NES, then yes. Yeah, I'd rather get this done first and then maybe move towards the procedural stuff later on if it works nicely. Anosial pixels shifting, something like that. Yeah, it was honestly a filter in GIMP. So this is the base image that I used. This was generated with render and the lava thing, the lava script, and then to get the animation here, I did animation and rippling, so like ripples or whatever. Yeah, and then I just dropped it down to 4 colors from grayscale. Well, it's still grayscale, but I dropped it down to 4 colors. So, oh, here we go. This is what it is. I already had it open. So I can get it looking, you know, like a darker blue, and it might. This is all of them together, by the way, and this might actually work. So we're gonna try it. We're gonna see if we can get this to work. You can actually kind of see it like animate there a little bit. Yeah, lava, yeah, lava. Akamaffin, how you doing? So the first step is getting the bitmaps, right? So I've gotten, I did that manually. You saw the command right here. This is manually getting the bitmaps. So the first step is I need to put that into the make file. Oops. Yeah, there it goes. So let's see here. Waves.chr is going to depend on images, waves, wave frames. What do I call it? Images, wave frames. Oh, it's gonna be a bunch of them, isn't it? Good on 64, what do I do? David Ganon, how you doing? Welcome. So animate bricks or background? Yeah, so it's animated background. That's what I plan on doing anyway. Not enough motivation. Motivation is a hard one. Yeah, honestly, if I wasn't streaming, I don't think I would have gotten nearly as far as I have with this project here, or even my previous project. All right, so what we're gonna do is we're going to wave frames bitmap, or wave frames is going to be, yeah, waves 1 paste 2, a bunch of them, 3, 4, 5, oops, 6, 7, 8, 9, nope, 9, 10, 11, 12, 13, 14, 15. That's 15 frames total. 13, 14, 15. Have you looked at the background looped around? What do you mean? If that animation loops, that animation does loop. Come on, why you got this way? This animation does loop. If that's what you're asking. If I go over to animation and playback, I'm gonna go a little bigger. This animation does loop, and it should tile. It should tile nicely as well. Octamer, how you doing? Not even 60 frames a second. It should seamlessly tile. Should. We're gonna find out. Yeah. So we're gonna use the other name table as a buffer, or are we banking CHR banks for the animation? Neither. So I don't have. I have CHR RAM, which isn't banked at all. So instead, I'm going to be using the 2 pattern tables as like a frame buffer kind of thing. So we're going to see how it works. We're going to see if it works at all. But we're gonna try. We're gonna try. We're gonna see if it works out or not. But I think it will. I think it will. Yeah, I think it will. I hope it will. All right, so I've got the frames, or let's actually remove the suffix there. The extension, excuse me. Like that. Okay, so that's all of the wave files without the extension. Wave BMP equals add suffix. I need to put a $sign there. $sign. Wave frames. Should. It should work. Wish enter worked properly in Twitch. It doesn't for you? Or did you actually accidentally hit like shift enter or something like that? Because typically that's like, no, enter a new line instead of sending or whatever. And then wave CHR. Like that. All right. I can have a list form, right? Or no, I can just do the what was it? Oh, the name of this. Got it here. Wave CHR. All right. And yeah. Wave BMP. What's the Sprite file? Waves.asprite. Waves.asprite. Like that. Hopefully this one takes precedence over this one. It should, but we'll see. And I need the command line for the frames. Exporting CLI. So B is batch, right? Yeah, B is batch. Then the input file, options. Hello, Valgus. How you doing? I am gonna see if I can get some animation working with the background. So we're gonna be taking this, which is a little animation thing I made before stream today, and we're gonna see if we can get that onto the ROM and animate on the background. So what I'm doing now is I'm looking through the command line flags for Asprite, the this image program right here that I use to. Well, this is where I'm keeping all the frames. Really, this is not where I made the frames, or this is where I'm keeping them. All right. List layers? No. Batch preview, save as. Save as. Yeah, this format. Layer frame. Ooh. Okay. Wave underscore frame1.bmp. Sunu Deer, how you doing? Yeah, we'll see if it actually works though, right? All right, let's just add a dummy waves. Wave CHR, that's going to be a phony. make waves. System cannot find the file. Oh, because they're all in. Yeah, okay, they're all in. What's it? Wait, no, it should. Hang on. CHR util waves bitmap. Oh, it did make them. That's cool. Captain Pie, how you doing? Just relaxing after washing dishes. Nice. I need to do dishes soon. Oh, because I called it wave one. Waves. Make clean. Can I make a clean image? Wave startup BMP. There we go. Okay. Folder. Not that one. Come on. Why is? All right. Whatever. All right. That's cool. I have them all in separate CHR. I actually want those in the same CHR file. Nice, dude. How you doing? Relaxing after a beer and 4 merge port. Nice. 4 merge port requests. Not bad. All right. So for the CHR, I actually want. I don't want that. I want a single file. Wave CHR to me waves.chr. And this guy, all right. Is going to depend on wave BMP. Oops. And we're going to do this. The output file first, and then list all of them, so it all goes to the same output file. Where's PR's best PRs? Let's make clean and rm startup BMP. Okay. This is for the first image in that. I want all of them though. All right. Continue make to variables. Automatic variables. There you go. Well, there's a Balmer peak with the optimal number of PRs per consumed beer. Okay, so this is the first prereq. Names of all the prereqs, but no. Names of all the prereqs with space between them. Yes, okay. So it is this one here. Where did it? Oops. No. There it is. All right. Clean and remove bitmaps. There we go. Okay. MPR over CV. Waiting for that research paper. Oh, this one here. All right. Beautiful. Okay. So let's go ahead and 15K for that. Whew. Let's go ahead and will that fit in what I have left over? Hang on, do I have a map file? Oh, because there it goes. Noise. You ever just want to burn your code to the Yes. Yes, I have. I absolutely have. Oh, it's been I do have a map file. Awesome. All right. So page, was it 14? $1A01. How much is that? $6. Ooh. What do I have? I've got like 4,000 hex, right? That's half of it, right? Is it? Yes, that's okay. Oh, it's gonna have to go on its own page. All right. Okay, so we're gonna have to put it in its own page then. That's gonna have to go in. Where's that gonna go? Bin breakout stop map. Yeah, let's put that in page 13. All right. Main. Page 13. All right, so this is going to be wave CHR data. Ink bin waves.chr. Come on. What part of the game this is background for? The main game I'm going to be using it for, I think. So this the black area here, ideally will all be that background. More beers were not possible since we had no one in the house. That's unfortunate. Camel Crown running up here. That fuel needs purchasing. Different 10 hours. Delivery beer? I don't know if I trust that. First function in on my own in high school. Nice. It's always satisfying when you graduate. I'll call it graduate from the tutorials and start like doing your own stuff without someone telling you how to do it. It's always a satisfying thing, and having it work. Boss fighter, how you doing? Welcome. Yeah. All right, so that grabs all of that and puts it in there. Let's see if overflows by 725 bytes. Okay. All right, this ain't gonna work. It's not gonna work like that. Hello, Beardy. How you doing, Alicia? Silly fanboy, how you doing? I didn't mean to, did I? Oh, I did. I apologize. Hello. It scrolled up too fast, so I missed you. I apologize. It's trustworthy beer since it's delivered by a member of the brewery. Oh, okay. Perks when living in Germany. Nice. We don't have that here. It's probably a good thing, honestly, here. It's pretty much functional oriented. When did Switch? Like a week and a half? No, like 2 weeks. Yeah, like 2 weeks. Where's my phone? What? Hang on. When's my flight? My flight is on a Thursday, I think. Yeah, my flight is 2 weeks from today. 2 weeks from today to TwitchCon. Keep forgetting. Get delivered American right now. Yeah, it's coming up. I hope to meet people. Easy maths. What is this? What is this? Oh, it's a lot of JavaScript that I gotta allow. Ooh. Oh. Oh yeah, this is totally something that we've done on a NES. Easy, right? Did I just move code? It's so easy on a NES. Absolutely. Sure. Multiplications and divisions and floating point stuff and oh yeah, this would be fine. It's Germany and get beer delivered, right? Meet me! I don't... Yes, I want to leave page. It took like a year to figure out. That'll run natively. Oh, I'm sure. Uh-huh. Yeah. Uh-huh. It'll run natively. Alright, so I need to split this up. I can't, I guess, put it all in a single file. So what is it? We've got each of them was what, 1K? Yeah, so that's 15K. How much do we have to a file? Well, a bank. I thought we had enough. 16. What CD images and wave frames. LSL. One of them is 1024. Okay. So we get 10 to 4 times 15 of them. 360. Which should be it should fit. Right? Like I'm not compressing anything. He's still knowing. Anyways, what are you working on? I'm working on getting an animation, this animation, on the NES. So I'm going to put this animation, where's my emulator? In the black area here, in the background area. We'll see if that actually works out or not. Do most NES assemblers use segments? I might not call them that, but yeah. So these segments are the banks essentially that I'm using. It's the way the mapper is set up and everything. NES SN ROM. Yeah. So 13. Start at 8,000 hex 8,000. Size of hex 4,000. A segment is a chunk of memory that I can swap out with the mapper. In this case, it starts at hex 8,000 and ends at hex C1000. Where is this? All right, right. So like hex C1000 minus hex 8,000 equals hex 4,000. Right. Just 16,000 bytes. Maybe, I don't know. I spent a whole 5 minutes on this. 5-10 minutes on this. So I'm not set in stone with the animation at all. It's more of the process of getting that animated on the background. Right, because once I figure that out, I can just open this up and draw something else in 15 frames, and then just recompile, and it will change it entirely. So I'm not really concentrating on the content of the animation right now. It's more of making it animate and getting that onto the ROM. Challenge for NES, yeah. All right, so do I like at least? This one isn't going to be updated at all, is it? It is. Hang on. Wait a minute. Do I have something else in that page? I don't think so. What happens if I just move it to another page? Let's just move it to page 7, because I haven't done anything in page 7. I guess something else is in page 13. Bin breakout.map. Yeah, I guess something else is just in page 13. Yeah, something else is in page... What else is in page 13? Hold up. Oh, that's... I remembered. Wait. That's the actual credit data. That's in page 13. Okay. Yeah, the names. That's what's in page 13. Why do I need all those pages? I don't right now. But here I can show you actually the pages that I am using. Let's go over to tools. Yes. SSP. This guy here. Back up to the game breakout bin breakout NES. There we go. This right here, page 07. Look at that. That massive green block is it just barely fits. That's the animation right there. So PRG00, that is the game code. PRG01, what is that one? That one is 00 is game code. 01 is the map data. So those are the maps. 02 is the title code, the title screen code. 0D over here is all of the other CHR data. All of no, that's the names. Excuse me, that's the names. That's the credits names. This page right here, 0E, is the rest of the CHR data, the other stuff. And this right here is the fixed bank, which is all the shared code. So like the map, the map decoding code, stuff for inputs and loading up CHR stuff and all that. Yes, this thing is pretty neat. It works. It works. It could use some improvement. It does work. It does its job nicely. Why is this not 3D like the Windows Drive pie chart? I'm disappointed. All right, so we've got it in there. So we're going to have a special function for this guy. Now we do have a function for wave, or not for wave, but for other CHR data, right? Yeah, index CHR data. Yeah. So what we're going to do again is we're going to actually copy this guy here, and we're going to put it over here. Tile count 16. Sure. Destination pattern table is going to be 7E. So this should duplicate it across both pattern tables. Oh, I need to. Now this is the game data, right? The game CHR stuff. So we got 0, 1, 2, 3, and 4. Should, right? Clock Hamster, how you doing? By the way, welcome. I lost credit. You can further optimize animation by using one image and only update the diff of the motion. Yes, you're not wrong there. But that might be too resource intensive for the NES. I don't know. Jojo, how you doing? Doing all right. Can't complain too much. All right, now let's make sure that this did what I thought it would do. I gotta go down to the game for. Go down to the game first. All right. I forgot. All right, so the game is only using the top row. I mean, that's fine. That is even better. I wonder if you can. Think of that, Jojo. I wonder if you can make a Counter 64 based off of a schematic. Probably. So yeah, I forgot that like all this stuff here like isn't being used at all in the game. It's just there because I never cleared it out. All right. Yeah. So 1, 2, 3, 4. No. 1, 2, 3, 4. All right, so we're starting at C0 for all this animation information. Okay. So what we need is a function to load in a frame of animation. Load frame. And this is going to have frame ID in A, like that. And I am going to want a lookup table for the start of these frames, right? Data wave frames dot repeat and an end repeat. Repeat. So this is going to repeat 15 times. 15 times. Have that. And that word is going to be 8,000. Or no, it's going to be we can actually use the label. Because there's that one byte at the very beginning that identifies the bank. Wave CHR data plus 1024 by I. Yeah. Let's go get there. But I should try something else we do later first. All right, so now we've got the start point of all of these guys, and yeah, each of these is going to be 1024 long, right? And what is that in hex? That's 1024 in hex is 400. Okay. Okay. Yeah. Actually, so it's only 15. What? Oh, it's just gonna be a full byte anyway. So the 7th bit is going to determine which which pattern table to draw it onto. 0 is top and 1 is bottom. So that's just the destination pattern table, right? So we're going to load up 0, 0. No, we're going to bit now. Store A in temp X. Index A, because it actually is an index this time, so we're going to use the index variable. And then we're going to bit that, and branch on minus to the second name table, or second pattern table over here. It's just going to be loading up something different. Store that into 2006. 6 over there. There we go. If this turns out intensive, I think a palette animations could do a decent job. Maybe, yeah. Maybe not with this with the exact input image data. But yeah, palette animation is also something that we could look at as well. And I might even animate this palette on top of the animation too, you know, to make it look a little bit smoother. Maybe, I don't know. We'll see. All right, we're gonna load up 0 again, and then just store that into 2006. You know, I need to what was it? Bit 2002 was it? I think it's 2002 for where's my, there it is. To reset the flip-flop. I should know this by now. Yeah, it's the status bit. Okay, the status thing. All right. Then we are going to load up index A and ASL it to multiply it by 2, so we can use it as a lookup into this table here, and transfer that to X. When you close the tab instead of muting for a second, you don't want to clip. Whoops. Done that before. All right, and then we're going to load up. Let's X is fine. Load up data wave frames at X and store that into address pointer 0, and do that for the second half of that as well. Okay. So now we've got the address to the beginning of of the data. Oh, you know what? We actually need to make this. What's the start address again? I say C0. Tile address is OC0. Yeah, and then this one down here is 1C. Yes, okay. So I do need OC and 1C there for the start address of the data. Yeah. And then it's just a big loop. Load up 4, store that into temp X. This is the page loop. So we're going to be reading 4 pages. So 4 chunks of 256 bytes, right? Right. Yes, 4 chunks of 256. Outer loop. Load X 0. Load Y 0, because we're going to use a pointer here actually. And then we're going to load up address pointer at Y, and then we're going to store that into 2007, and we're going to increment Y, or INY. Branch not equal to outer loop. If it is equal, we are decrementing X. We're going to decrement X, and we're going to increment address pointer plus 1. Yeah. And then we're going to, or no, let's do that one first. Decrement X, branch not equal. Okay, we're just going to call it loop actually, not outer loop, because it's just one loop. Like that. Okay, now this should load up a single frame. So let's edit game. Come down here. And for now, I'm just going to, well, load up 0, 0, or 0, and JSR to waves load frame. So this is going to put the first frame on the first pattern table, in theory. Let's see if it actually does. address pointer undefined because that needs to be address pointer 0. Same thing here. Hey, what the follow? Appreciate that. Size of void. I like that. That's a good name. All right. So, actually, let's just break on this right here. Okay. Not that. Let's open up one of these. All right. So let's watch this break. All right, VRAM address is OC 100. That's good, I think. Address pointer is 8001. That's good. All right, looks like it's right in the right spot. It's not right in the correct data, however. What is that? It didn't change the page. Change the page. I forgot it needs to change the page. All right, so right here we'll do the page change stuff. No, not game. I want main. Where is the other one? I just want to copy the code essentially from the other one. Load up A as 8,000. Push it, and then we are going to load up 7. I said it is 7, right? This page up is a pain on the bottom of my side. Coming from SNES to NES. Fun fact: in GCC, the size of a void is 1. Really? Well, I guess it has to be something, right? What am I looking for? The pages. Yeah, page 7. Okay. Load up 7, and we're going to JSR to the select page. Select page. Let's see, one select page. Then at the bottom, we are going to do that and PLA. All right, let's try this again. Now that we've got the correct page in there. Yeah. What about Clang? I don't think I've actually used Clang, honestly. All right. So this time, okay, it did change the page now. Increment Y. I am loading 0 and Y every time. Because there need to be 2 loops. Because I have to reset Y on... actually, I don't even need to reset Y. No. Because it'll loop around. It'll loop around, so I don't need to... Oops. I don't need to bother resetting it. Because if it's 0, it's going to fall through. I do need to set it first, though. Oh, I did. Okay, I did. All right, try that again. What is the point of RTS? Sure, RTS? Sure, why not? Same Clang. All right, and the page. There's that. So we're now on the correct page. All right. That looks better. Okay. So let's break on each of these guys. So 1, 2, 3, 4. Beautiful. Look at that. Select the previous page. RTS. Beautiful. Beautiful. Okay. So the first thing I need to do, or the next thing I need to do, I think, is get this static image on the background. Yeah. So for each row, I need to repeat one of these essentially. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So there's going to be 8 rows, and yeah, okay. So it's an 8x8 tile animation, right? Yeah. It's a non-standard extension in the C library. Say in the C standard, void is not a complete type, so size of void shouldn't compile. But to make a pointer arithmetic on void pointers well defined, void needs to have a size. Right, so the first thing I need to do to get it on screen is to actually wave draw background. Draws the waves tile IDs on the background. Yeah. So I said, what was it, 8? Okay, so 32 divided by 8, what is that? I should know this, shouldn't I? That's like 4, isn't it? Yeah, that's 4. I'm gonna double check myself because I've been wrong before. It's 4. Okay. All right, so I need a row counter that goes from 0 to 7, and a column counter that goes from again 0 to 7. Or 7 there, and a repeat per row that goes from 0 to 3. Pesos? Guess taking the 8 exam tomorrow morning. Nice. You've been studying that for that for a while, haven't you? Something I haven't studied. Yeah, right. Now I can do a lot of these with the repeat counter, can't I? Probably. Yeah. So the rows are going to be a little bit of a problem though, because 30 divided by 8 is not 4. That's a 3 dot number. 3.5, I think. Yeah. No, 3 dot something else. I appreciate that. Been trying to study for a while. Trying to study. It's not $1 billion. It also freaks me out when I get the dashboard page of all the weird icons. More of a learn if it's the first time. More of a learn if it's the first time, and then stuck at studying because literally everything distracts you. Yeah, that never helps. That never helps. All right, so let's start with the innermost. So we've got the column, right? So we're gonna load up C0. First row, first column. How do you spell column? Yeah. First row, first column. And we're going to load up x to be 8. Yeah. And we're going to let's load up x to be C0 and load up y to be 8. Because I can increment x, right? So we're going to store a. First, hang on. First we need to do that and load up 220. Store that into 2006. There. So that sets the start address, so we're going to start writing it. I've said that before. But all throughout school, I barely studied. Same, honestly. I hate certs. Of course, I went through, was made to pass the exam, not to learn it. Yeah, I can't stand that kind of stuff either. Yeah. Where you're studying to memorize instead of studying to actually learn the subject. I don't like that at all. At all. All right, so we're not going to store A, and so we're going to store X at 2007. Increment X and decrement Y. Branch not equal. Back 1. Top loop. This is going to be row loop. Or row 8 loop. No. Frame row loop. So a row of the frame, not a row of the screen. Yeah. Okay. So this should write a single row. Yeah. And let's do screen row loop like that. Load up A to be 4. Store that into index A. Decrement index A, branch not equal to top loop. So it should write the same 8 tiles 4 times on the top row. Let's see if it does that. Oops, no. All right, I'm putting this after the load frame so I can just see that it does something. And this will actually come before we draw everything else, because this is going behind everything. So these bricks will be drawn on top of it. Now, there will be a little bit of an issue when I have to clear these bricks, but I will come back to that later, I think. I'll need some sort of lookup or something to make sure I put the right tile there. Where's... wave draw background. Oh, I already had one there. So my session that was that was my IB classes because the test cover such a wide area that you literally had to learn everything. This is what you need to pass the test was basically a review of the entire year. CMOS certs recently, not educational certs, but crypto certs, and certified code. I need to, I don't know, review that because I understand certified code at like conceptual level, but not on a practical implemented level. Cert is a document that can be verified saying that a particular authority vouches for the identity of the certificate holder. Yes. Yeah. All right. So at this point, we should have. Yes, we got the wave data in the pattern table. So let's watch it not draw correctly. Oh. What is it drawing? Oh, it's drawing this stuff because it's it's on the second what's it? The second pattern table, isn't it? Yeah, I think this is the second pattern table it's using. Yeah, okay, it's on the second pattern table. So let's so I don't have to change other code right now. Let's take this and just do 80 like that. Just so it's gonna write the same frame but on the bottom pattern table instead. Right, yeah, okay, so it just moved it to the bottom now. All right, so now we should be able to see the frames for it. There we go. Let's break on the RTS. Oh. Okay, that didn't work. That didn't work. That didn't work. Okay. Let's restart that. Game. Yeah, it's broken. Just a little bit. Just a little bit. All right, so we're gonna decrement A. 1, 2, 3, 4. Okay. Because I reloaded at the top of everything. Okay, that's why. That's why. So that top loop. Something else. Screen row loop. I need to jump to the right place. But this should work now. Okay, we've got a row. Beautiful. Beautiful. Actually, I might want to, what's it? I might want to unroll this a little bit. Yeah. So let's unroll this loop here. Load X to I times no C0 plus I. Repeat 8 times. And the repeat. Okay. So this is going to happen 8 times. Well, this right here is going to happen 8 times. All right, so this should do the same thing, but have an unrolled loop in the middle of that. Bloodware. Code starts, however, document saying that the program conforms to certain requirements, including instructions on how to verify it. Huh. No authority required, really. Green grass. All right. so here, I don't need to load up X there, whatever. There we go. Look at that. Yes, we're going to use that unrolled loop, I think. I don't need X or Y here. Okay. Draw a row of the animation frame. That's what that is. Repeat 4. Come on. This is going to be R. So I'm basically doing the same thing as all this stuff. I'm just unrolling all of it. This one I don't need the R though. Right? Maybe. I might want to actually keep the loop in there for this one. Yeah, I'll keep the loop in there for this one to make that code a little easier to read. Yeah, so I'll keep that in there. Okay. So once it does the screen roll loop, it's going to increment index B. Now, index B is going to be the row of the frame. Right? Probably. Which means I would have to you know what? Let's do that. Fish face. I'm trying to think of the best way to do this. Because I need like a lot of. It's going to be a few nested loops essentially, right? Go with that. There we go. All right, so that's one. That's one loop. I'm just going to copy this for now. It's going to grab this, put it there, and it's not going to be C0. It's going to be C8, right? Same account with the big old complexity. Okay. So far, so good. So I need 8 of these essentially. I need to do this loop 8 times. So that's what top loop is essentially going to be. Okay, yeah, I've got row of frame. All right. So the top of it is going to take is going to compute what the top one is going to be. Right? Hang on. Wait a minute. All right. That's correct. All right. 8. Yeah, it's gonna calculate what this byte is gonna be, the start value of the row. So that's gonna load up index B. ASL it 3 times to multiply by 8, right? Clear carry, add carry, C0. That ain't gonna entirely work. Yes, it will. Yes, it will. Because that'll be fine. That'll be fine. Because we're still in 256 bytes. Tronics, how you doing? It's one of those languages that is good to watch someone else rather than coding yourself. I don't know. I really enjoy it. I enjoy it. All right, I'm going to store that into temp x. Okay. Calculate the value of the first tile index in the frames row. Right. So the first one should be, the first loop around should be, I appreciate that. Should be C0, then C8, then D0, then D8, and so on and so forth. So what I am making is a breakout game. Specifically tonight, I am taking this animation that I made before stream in like 10 or so minutes. And I'm going to put that animation on the background, so the black area here. So that's what we're working on right now. I just want to write something in assembly and see it work. It really is, even if it's something so trivial. Yeah, I'm not sure this is trivial anymore, but it is satisfying. It is very satisfying. But yeah, so far we have a static image in the pattern table, so we can start drawing it on the screen now. So that's what we're doing. We're starting to draw that image on the screen, and I've got one loop of it so far, one row of it. Let's go ahead and remove that. All right, so this is an entire row. Increment B. Compare that to 8. Scratch carry clear to top loop. So this should draw 8 rows of tile data. Let's see if it actually does. That one, this one. I need to go down there and do that. I mean, that's not the right spot to be stopped at, but whatever, that's fine. Okay. So let's go there. 1, 2, 3, 4. Okay. Oh. I've got the compare wrong, but I mean, yeah, I got the compare wrong. But we're making progress. This is looking good so far. All right. Recently just learning Rust. I'm at a point where SM seems easier to learn than Rust. Progress, right? We're probably getting used to writing C. So that needs to be 7 right there. So let's change this to 7. That's a 3. There we go, 7. You know what? Let's make that. Here, reload that. Game. Okay, it doesn't exit that correctly. Oh, because I don't load it. Duh. All right. I don't load it. I did that before, didn't I? I think I did that the other day as well. Well, I did the exact same thing. Look at that. Okay, so it draws first, and then everything else draws on top of it, which is good. That's what I want. Beautiful. Beautiful. All right. All right. So now I just need to do that. I need to do that 2 more times, and then the third one, I need to like chop off one of the rows. This is what a black hole looks like from the inside. Something like that, yeah. Here to help. Well, thank you. Nice, dude. How you doing? I don't think I said hi to you yet tonight. Welcome. Rust looks super complicated. I haven't tried Rust. All right. So we got that. Load up 0. Store that into index C. Number of frames vertically. Increment index C, load it, and compare that to 2. We're going to compare it to 2. So it won't fill the screen. It'll almost fill the screen because the last set of the last full row of these frames will actually go past the end into the attribute table, which I don't really want. So I need to stop it before it gets there, right? So let's see what happens here. All right. So let's break over there. Oh. It compared and did nothing with the result. I'm pretty sure it's still top loop, right? Oh, no. So this is going to be, let's see, top frame. I need better names for those loops. All right. Going is fun. I like going. Really look forward to seeing the end. I'm looking forward to it too. Do the other round start the first iteration in the middle, so the next test is simpler. What do you mean by that? Bridgewater, I'm not sure what you mean by that. Always go towards 0 as the 0 flag. I mean, I could, but let me get it working first, yeah? That'll make it not crap. All right, so I'm gonna get on there. Yeah, because I'm not using in these index variables in any calculations, right? Well, I'm not using C anyway in any calculation. So I can like start at a number like 2 and decrement it, but whatever. All right, so let's add one more to it. Should be 3 actually. Matt Genius, how you doing? Golang is a good choice. Golang functions as variables actually help me understand delegates. There you go. Yeah, I'm breaking the background now. I'm trying to animate it, and so far I'm getting the static image on the screen. That's step number 1 of this static image, and then it's animating the frame. So I have the animation compiled as frames, but step 1 is getting the data on the name table. And then going from there. 2, 3. Okay. Now then, after this, I have 1, 2, 3, 4 and a half. So 4, it's 8. Wait, that is 8. So I can go another one, and I just need to write 1 row then. Well, that would be too bad, would it? Let's go an extra one. Oh, okay, an extra 2 rows. That wouldn't be bad at all, actually. Oh no, around 2 weeks ago I wrote a bot which notifies me on updates on my services. 1 weekend I already got annoyed by it. Oh, uh-oh. I saw the background last year accidentally and now on purpose. Yeah, right. Well, this is less of a mess up, you say. Oh, that doesn't look the best right there. Is that correct? Is that the bottom of that image? No. Well, that's over here. It is cutting it off a frame too, a row too early. Isn't it? Because this right here is that right there. And then it's got 1 row. Oh wait, maybe not. Or no, where is this? Where is this? That isn't anywhere. This guy's not anywhere. So yes, this right here isn't anywhere. Okay, so I have compare for the rows screwed up. This one needs to be 8. Right? Yeah, it's not by 1. Can it be the other color? Can it be other than another color other than green? Yeah, I'll make it a different color. But for now, I mean, I just set green a while back, and I didn't actually try and I didn't actually change it. All right, so this one. We're gonna step to this a little bit. So this is screen row loop. Okay, and where was the change we made? We made the change here. Okay. There we go. Now it's filling out more. All right. So now, all right. There we go. That's better. That's better. Ow. Try to have head for off by none. Yeah, right. Uh-oh. What is this? Attribute data is 0, 1. 0, 1. What? I'm not going to worry about that right now, I think. That was actually outside of everything, so I could be written somewhere else. I had to stare at a spreadsheet that was half highlighted in bright yellow. A 7. Oh man, that's a quick way to get like strangled at the office, right? Close version heard last. Yeah. So, I don't think I'm actually updating the the palette manually every time. So let's see. What did I have as? Oh, they're gone already. So this is going to be that color. This one is going to be that color. This one is going to be that color. So that isn't too bad, right? Of course, I could also, instead of making that gray, I can make it that color. That works too, right? Of course, then again, I would be limited to using just those colors then in for the bricks as well. I don't know about that. Pretty, yeah. So we'll see. It would be good if bricks were a different color, right? Which is troublesome. Because they share the background layer. A little troublesome. So we'll see. We'll see. Yeah. All right. So for the last loop, the last loop's gonna be a little challenging. 1, 2, 3, 4, 5, 6. Because I need to loop for 6 rows of the frame instead of 8. In fact, actually, you know what? Hang on. Hang on. Load up that frame. Yeah, okay. Yeah. So this right here is the one that I need to. But I'm using this in a calculation. You see. Actually, if I just load up, no, because I need to go to the top loop. Let's just go ahead and copy it. Let's just copy it. Let's just duplicate it. Yank that. Paste it down there. Last row of frames is 6 tile rows, not 8. That's 4, 6. All right. So let's see if that works. I suppose I can change out that immediate value to an address, a non-immediate value, but we can make sure this works first. Shouldn't bricks be sprites for palette efficiency? They can't because that's far too many sprites. It's only the ball and paddle. Yeah, it's only the ball and paddle on sprites, but that's too many. That's far too many sprites per line, per scan line. Yeah, so I've only got enough for 8 on a single line, and I've got like 24 tiles across per map. So that's not really feasible, unfortunately. All right. So let's jump down to there. Okay. And then down to there. Okay. Am I using index C? I am using index C. Let's use temp Z then for that compare value. Load up 8, store that into temp Z. Number of rows in the frame. So here, we're going to load up temp Z, compare that to 6, branch equal, or branch not equal over top of it. So RTS there. So if it's 6, we're done. We've already we already did that one last loop, right? Otherwise, we're going to load up 6 and store that into temp Z, and then jump to top frame. The at and then top frame. Like that. Get a special bricks in the sprite layer though to maximize. I could, yes. I would need to make sure though that I don't have more than 4 special bricks to row. I didn't get rid of the RTS. It never would happen. All right. Okay. Compare that to 6. Temp Z is not 6, so we're going to. It's not equal, so we're putting it in 6 to the top of the frame. Beautiful. Okay. Beautiful. All right. So let's load the frame there and load 8.1, that frame there. And what was well, go back to the internet. I need to figure out where that's happening. Okay, so you have 2 different frames on the 2. Yes, on these 2. So now let's NMI game, and we are going to decrement temp W. Because temp W isn't used anymore, right? Branch not equal over there. Otherwise, if it is equal, we're going to first up load up 4, store that to temp W. I need like an odd even kind of thing going on, don't I? You know what? We'll make. All right. Waves anim weight. Res 1. This is going to be number of frames to wait between animation frames. Oh, you can't even see this over, can you? When I first really started to understand what the articles on the NES Dev Wiki are saying, I got pretty overwhelmed. Seeing the process streamed on video just confirms that. It's not that bad. Waves, anim, toggle. Not toggle, odd. There's one. So this is pattern table. That. Load up waves anim or anim odd branch on equal. Okay. Branch on equal over load up 1, store that into waves anim odd, otherwise loading up 0. Jump to table. When you hit the bricks, does the background image appear? It won't yet, but I plan on it. Or I could do, I could have like a board background kind of thing for when the bricks disappear. That way, like I could line that up with the attribute table, and I can give the play field different colors entirely, and yeah, I don't know. We'll see. But currently, no. The image, it'll replace it with black. Same. So no, it won't do anything different. All right, set table. This is actually going to matter. Background pattern table address. Now the sprite pattern table address I can ignore because the tiles are going to be the same spot always, and those aren't going to change. So I just need to worry about the background pattern table, which is 2000 at that one, which is bit 5 or 04. Load up this guy, but take this one, make that 0. Store that into 2000. Grab it again. Like that. All right. Zero, store that into waves anim odd. All All right, Captain Bug, you have a good night. Thanks for stopping by. Handsome my eyes. How you doing? What assembly language are you using? 6502. Yes, 6502. Oh, I got an error. Waves anim add. No, that's anim odd. Where's add? Oh. Odd. Waves anim odd. What? Oh, I did it again over here. Godfather, how you doing? Welcome. All right, so this is gonna switch back and forth between those two name tables, but I don't update the stuff that's on the pattern tables. But it doesn't update anything that's on those pattern tables. Okay, I lied. I lied. I just lied, I guess. NMI game. It resets it somewhere, doesn't it? Where it is freaking, you know. All right, so I need to actually put that into a variable. CPU control as one. Where's your food? I don't know where your food is. I won't feed you. Oh, because I didn't save this file over here. Alright, let's try that again. Nope. Okay. Cool. Fantastic. Wait. Wait a minute. What? It's broken. It's broken. Is NMI never does it never hit NMI? Doesn't hit that one. It never hits NMI. So where's the food? Yeah. All right. What's going on with my NMI vector? Oh, well. 4C. What is 4C again? Womp womp. Yeah. Ain't that one. Absolute. Okay. Eight one E. 818E. The 81E. Oh, it's up here. And my game. NMI is disabled. Why is NMI disabled? Did I? Huh? Oh, was that because I copied it from up top? I think so. Wait a minute. Milo Christensen, how you doing? Welcome. Afghan command. Try yum instead. Yeah, right. Never learned 6502, but an emulator 62 was my introduction to fourth. Oh, really nice. Not bad. All right, so for some reason it's not it's not doing the NMI at all. I don't turn it off. And the NMI stays on. Load that up. Okay. Well, let's see. Let's drop a breakpoint there and reset to see if it at least if it goes through it once, because it should. Okay, it does. What happens? I don't need the rice spice stuff. Decrement the animation weight. Okay, no animation. That's zeros, isn't it? It's zeros. Mm-hmm. So let's go ahead and take that. So the first run through it disabled it entirely. I never did it again. Okay, it did it once. I saw it do it once. It's equal. So it loads 0. Okay, it's backwards. It's backwards. Try it again. All right, this is gonna look janky. It looks janky, but that's fine. I mean, this is working. So far, it's working. So now, between the frames of animation, I need to populate the other name table, the other pattern table. Wiggle, wiggle, right? Yeah. That's gonna be like 8 frames. That needs to go across 8 frames, so I actually need to go a little slower, doesn't it? I might need to. Ooh, might need to slow this down even more because of how much time I have available to me in the NMI. Did I reassemble? I don't think I did. I didn't. Yeah, so let's have a look at how much time I actually have in the NMI. I've only got a few frames there. Don't you just update the CHR? You need to change the name table. No, I'm not actually changing any name table stuff. I am updating the CHR RAM. So I need to write an entire kilobyte of RAM of memory. And that's going to be spread over like 8 or so frames. So 16 tiles per frame. And that's going to have to be like really unloaded. That is a lot of RAM, yeah, right? So that's going to have to be unrolled quite severely, I think. Yeah, so let's waves unrolled row 1 or row 0. Half a millisecond, I thought the stream was offline. Half a millisecond. The bricks aren't clear. Fix split. Jojo. Some fourth influences are faster than others. Gotta go study. All right, Jojo, no worries. Have a good night. Thanks for stopping by. Okay, so this is gonna take the first row here, right? Yeah, I need to like completely unroll this to an absolute load of an address, and then a write. So, oops. Repeat. This is going to be repeated 16 times, once for each tile. Tile loop. And then for each tile, I also need to repeat 16 times for the pixels. Bytes on the tile. So this is going to take, load up, wave CHR data plus it's going to be T times 16 plus I, right? Store that into 2007. Or no, this is going to be 0C. So this is just, oh boy. So in A, I'm going to need the name table, I think. Or not the name table, pattern table in A. Load A, or branch equal over here, so that's going to be that one. Okay. It should work. What are those repeats? It seem like loops, not necessarily. Correct. This is going to be an unrolled loop, so it should expand this to an absolute address, a lot. Yeah. So it's a long list of instructions. So this is what it came out to. And it looks correct so far. So it starts at PAL game. What? Address all Fs. That ain't right. Address 8002. Load PAL game. What? Zero times 16 is 0. Plus 0. Why is CHRD? What? Oh. It's because of the... Oh, it's because of the bank that's loaded in right now. That's why. That's why. Yeah, woo, macro. Captain Longfox, how you doing? Welcome. So let's see if this fits in a single frame. I hope it does. All right, so after all of that stuff, load up waves animal. All right. Goodness gracious. Let's actually start. Let's put a breakpoint there instead. A. Hit A, right? Okay. Oh boy. I don't know if we're gonna make it. We're gonna make it? I don't know. This is gonna be close. This is gonna be very close. I have too much of this crap open. That's why it's slowing down a little bit. I'm not sure which one it's writing on. I think it's writing on the top one. It is. It's wrong. It's the wrong data. It's the wrong. It doesn't matter. Whatever. We're gonna see if it fits. It does not. Oh boy. Okay. It don't fit. Yeah, I don't have it. I don't have the 10 keys. The numpad's gone. Look at a new keyboard. Do I need the 10 keys and F keys? I use the function keys all the time. 10 keys, I don't. Yeah. Function keys are also optional. For some people, not for me. I need them. All right. So how much do we have? Oh no. Yeah, we've got a few tiles left. Okay, so that's not nearly fast enough. So if I want to be able to do it in one frame, one row per frame, I need to not do like sprites or something like that. Oh, okay. How many frames? How many lines into the next frame does it go? Oh. 2 scan lines in. Oh boy, that's a little much. That's a little bit much. All right. Okay, so I might have to double it then. I'm gonna have to double it, because if I double it, I can do half of the row, right? 8 tiles. Yeah, I can do 8 tiles. Unless I want to not draw the bottom row of the screen. I can do that too. Control, Alt, Shift, and Super keys are very necessary for me. Although, well, maybe not super, but it's convenient. Yeah. For some reason, pressing Control doesn't cause the press any key to continue thing to continue. Because Control is a modifier typically. So it's not sent as it's pressed. It's sent with another key. Sometimes, I don't know. Depending on, I guess, the APIs. Depending on how that program is reading the keyboard. Some of the cons are the cons. Maldor, how you doing? Welcome, welcome. Yeah, so I'm gonna have to do something a little different here. There's no CHR. No, there is not. There's only DMA for the sprites. So I have a source address for that, but I cannot specify the destination address at all. Yeah. All right, so I'm gonna have to row 1, row 0A, and that's gonna be, we're gonna cut this in half. That's gonna be 8. Okay. I don't think I need to actually cut it down that much, but it being divisible, whatever. But I think it's fine for now. All right. Yeah, peasants, any 2000 language professors. Listen, here you go. All right, so now it'll be writing on the top there, I think. Yeah, it's going to write on the top. I mean, it's garbage data. Don't worry about that right now. It should get halfway. So this will be like the last tile right there, right? Yeah. Okay, so it got halfway. Got 8 tiles in before the end. All right. 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 frames per animation frame. What languages I use here? I use 6502 assembly and Golang for my tools. But welcome. How you doing? All right, so I'm going to want to look up table for yeah, for that's actually just one row of the frame, isn't it? Yeah. I don't see sharp maybe not in COBOL. I mean, not here anyway. Data wave frames 8. Repeat. Thank you for the follow. Appreciate that. So not 15, but we're gonna do like what, 29? No, 30. Full on 30. 30. Oh wait, no, that's no. Do I want one lookup table per frame, like each row? Maybe. Maybe. Is learning some language worth it, or should I just use a high-level language like C#? It all depends on what your goals really are. I don't know. I think it helps understand the lower level of the computer. And personally, it's helped me with a lot of planning, right? Breaking an issue down into its smaller components, which is pretty necessary when you're working with assembly. It isn't always necessary in higher level languages, but it helps immensely. So instead of just like diving into something and just hammering out code, assembly makes you like plan it out first, right? And admittedly, I didn't actually like plan this out like at all before stream, because I like I said, I did this like 10 minutes before stream. I'm like, ooh, wait a minute, I could probably try to do that. See, that's why I'm going a little bit slower today, I think. Well, kind of shooting myself in the foot there. All right, so this is gonna be frame 0, row 0. Repeat. Word wave chr data plus well, the frame is 0, so the plus I times no, it's just going to be I kind of want to like use a lookup for this, or oh, this is just going to be start values, isn't it? How much will this suffer if I use a pointer here? I wonder. Constantly writing code is fun, right? Just some guy. Did I say hi to you yet tonight? I don't remember. But hello. The difference in languages, is similar. Yeah. Yeah, so we're to learn first, right? And they're all different. Yeah. They're all very different. All right, so what happens if I load up wave chr data, store that into pointer 0, load up wave chr data, store that into address pointer 0 plus 1, and then in the repeat load y 0, load a address pointer 0 at y, store that increment y. This is only going to write one row. Yeah. It's only going to write one row, but let's see how much longer this takes. So this, okay, so right now this took a few scan lines. We ended on scan line 255. Yeah, that's close. All right, so this is gonna make things worse, I think. Well, it's going to make things worse, but just how much worse? I don't know yet. Let's find out. All right. Oh, that's great. It's better to learn machine code first and work your way off. What could possibly go wrong? But assembly machine code is what all languages eventually end up being, more or less, yeah. All right, so now this is just going to be a lot of lookups, or yeah. All right, so this is going to be significantly worse, I think. Because instead of taking 3 cycles, we are taking 5 cycles. It's an extra 2 cycles per instruction. Okay, fine, make it better. As always, C64 Basic is slow. Handwritten ASM is super fast. Wow. Everyone knows that Haskell is best language learn first. Actually, what I can do, I should still have a bunch of RAM that I can use, right? Probably. Oh, we're almost done. We're almost done. If I can write this stuff to RAM instead, and then run it from RAM, oh, That just barely makes it. Holy crap. Look at that. It just barely made that. Wow. In all seriousness, if you want to learn how a computer operates while learning your first programming language, C or C++ is the way to go. Yeah, so that's oh boy. That's cutting it really close. Holy crap. I mean, this might work, though. It's cutting it really close. Pascal? C would probably be more useful, yeah. It's cutting it really close, though. Alright, well, let's... But doing this makes it a little bit more flexible, because I would just need to change this for the start value for the row, which is like a one-time lookup. Does it break? It shouldn't. Better not. Nah. Collision still work fine, thankfully. Yeah, so all right, so I think I might keep it that way, even though it's cutting it really freaking close. Pattern table in A. Row to send to the BPU. Yeah, so let's load that stuff up. And then the row is going to be we're going to add the offset of the row of this of the frame, right? So that's going to be current row times 8. So we're going to load up waves current row ASLA that 3 times. Clear the carry. Add that to address pointer 0. Branch carry clear over that, and this is going to increment address pointer 0 plus 1 to handle the rollover. Okay. So both of these guys are going to reset the row. Like that. This guy here, at the end of this, is going to increment the row. And I might want to do this calculation like after it for the next one. Maybe. Maybe. We'll see. We'll see. Because this doesn't necessarily need to happen during the NMI, as long as it's the correct value when this code is executing. So I would need to set it up once beforehand, and then just make sure that I update it after I run for the next frame. Yeah. Well, let's see if this works. Well, wait, it's going on if I. Where is that? Give me something. 3, 2, 6. This guy, and over here. Okay. I was just gonna do something. I forgot what it was. Oh right, changing the page. Yeah. And then PLA on that. All right. Joe Best, how you doing? Hello, and Uber X, welcome, welcome. Faster retiles from RAM than ROM? Not really. Not unless it's in zero page. No. So what I was thinking with RAM before was have self-modifying code in RAM essentially, where I'd be loading absolutes. Or, yeah, loading absolute addresses, but I'd be changing those absolute addresses in RAM, basically. Similar to what I'm doing with the NMI. My first language was AppleSoft Basic. Other languages that I learned early included Integer Basic, CVM Basic, AppleSoft Logo, Borland, Turbo Pascal, and something called Function Machines. I'd start on the wiggle. Oh, so this is like for each frame of the animation. I'm keeping it at what it can do, the fastest it can go for now. Slowing it down is certainly an option later on. I did not speak Italian, no. Yeah. It's what cripples the mind. It's teaching should therefore be regarded as a criminal offense. I don't speak English, but I watch you. Well, thank you. Appreciate you being here. Was so misguided. Humans were resilient. I'm not so sure about the JavaScript programmers, right? Okay. So we're gonna see if that pushes us over the edge for timing. I don't think it does. We are running really close on timing, but it didn't. Okay. That is still being executed, right? I think it is. Probably. Yes, because it you can see one row now is not moving at all. So it's right in the same row essentially, which ain't right. But where are we on timing anyway? Oh boy! Now where's these are all, I don't know what any of these are now. These breakpoints. Can I remove these breakpoints, please? Come on. Remove. Remove. Unrolled. This guy here. We're gonna break at the very end of this so we can see what the scan line is when we stop. When I stop. Right about there. I don't need to do the increment Y there, but whatever. 259. We've got like 260 scan lines. We have a single scan line before. Oh boy, that's close. Your goal is currently to stay within 60 frames. My goal is to not glitch out the screen. No, this is not HTML. This is 6502 assembly. Joe Best. There's a problem with parts of the background as though the tiles are being removed or being replaced in empty space instead of the animated bit. Oh yeah, so the animation, like, it's not actually doing any animation. It's just writing a static row, essentially. So yeah, I'm aware of Also, how does this work with the half brick offset levels? What do you mean by that? The half brick offset levels. You mean horizontal? That should work fine because it draws the entire background first and then draws the playfield on top of that. Yeah. Early release, how you doing? What's some great resources of good assembly programming? Yeah, what Bridgewater said, I guess. What I used was, it just won't work for everybody, but this is what worked for me. If I can find my chat window. Was this. No, Joe, that's fine. That's fine. I don't understand Italian though, so I won't be able to respond to you if you talk in Italian. Why do I have this open? I don't need that open anymore. But yeah, so those are the manuals that I used to learn assembly. That won't work for everybody, but yeah. Mirroring tiles horizontally and vertical might look good on this. I can't mirror background tiles. I can only do that for sprites. Assembly is difficult. It can be, yes. If you haven't done any assembly before, a lot of the the methods of doing things are might be a little difficult to wrap your head around. But once you get that down, once you figure that out, it's fairly straightforward after that. I think it's fairly straightforward. Yeah, it can be difficult. It can be. It depends on if you know any other programming language, like if you know C or C++ beforehand. I would not recommend learning assembly as your first language. All right, so what am I trying to do here? I am starting at the top every single time. Okay, you know what? We're gonna prepare all this stuff beforehand. Yeah. Waves, prep, CHR, right. So this is something that will happen outside of NMI. Yeah, no worries, Joe. No worries, Joe Best. Thank you for watching. I do appreciate it. Sets up addresses and variables for waves unrolled. Okay. So I need some dedicated variables for these things. And they need to be in 0 page here. Waves CHR destination. That's 2. Waves CHR source. That's 2. So this is the start of an 8-tile row. And this is CHR address to start writing. Okay. So the first one is going to be OC 1000 is the destination. Yes, I am a programmer. I am looking for work though right now, so I don't currently have a day job. I just do this. I am looking though. I am looking for a job. Hopefully one shows up soon. All right, then waves. CHR source. I'm gonna store something like that actually. What am I? Store. Load wave CHR data. Okay. So, first, write the destination CHR address. And then this is figure out source address start. 3 a.m. 3 a.m. What are you doing awake? Go to sleep. Thank you for stopping by, though. I do appreciate it. Have a good night. All right. It is 9 o'clock for me, so it's not nearly as late as it is for you. All right, pattern table in A. No. This is going to keep track of all that stuff for us. No. So we're going to load up something. 2100. So 9 p.m. at night. So 2100. Yeah, I'm a night owl. I cannot get up early. Oh, you have a good night. Thank you for stopping by, Joe Best. Okay, so this is going to keep track of the frame we are displaying. But no, it's going to be Animod. Okay. So this keeps track of top or bottom, essentially. Branch on equal to bottom. Bottom here. Jump to row offset. So these guys here set the start. That's the very beginning, right? Who hurt you? Vlad, how you doing? Welcome, welcome. I am writing an assembly to learn assembly specifically for NES games, so I can reverse engineer other NES games, essentially. and that was kind of a rabbit hole, and now I'm writing NES games. So there I am. I find it kind of fun too. I find it fun. Okay. So then the row offset is going to take the wave's current row, ASL that a bunch. Oh, that's what this is here. ASL that a bunch. Wait a minute. No, it's not 1C0. It's... Is it? Hang on. What's... Wait a minute. 1C00. So... Guess it is. Never mind. Oh, right, because the tile ID and the address index are different because... Yeah. ASMLP. Yeah, so that is correct. I need to multiply this by 16. Right? No. How many? Okay, so I need, given the row, I need the number of bytes each frame row is. So I need the number of bytes 8 tiles is, which is what, 64? $128. Okay, I don't think I want to be shifting this then. Well, I mean, it's all gonna have 8. Well, it's gonna have 8 rows, but So I need a lookup table for this then. I need a lookup table for multiplication here. I think, right? Well, wave frame, no, a wave row offsets. How about that? So this is going to be, well, yeah, eight rows. Okay, eight rows. And we're going to use a word for this. So 2 bytes, and that's going to be 16 times 8 times I, right? So this is the number of bytes per frame row, or half of a CHR row. And then this, I, is the index of the frame row. Yeah. So the highest this will be 8. Oops. So that's 16 times 8 times 8. 1024. Well, that's the highest W is 7, actually. That's going to be 7. 0 to 7. So yeah, it repeats 8 times, 0 to 7. Yeah. So 16 times 8 times 7, 896. Sounds about right. Yeah. And that does not fit in a single byte. That fits in 2 bytes. 896 plus I. Now this is just for the start of the rows. That's all that is. This is just for the start of the row. So if I assemble this real quick, reload, and have a look at the data real fast. Try that. That's down here somewhere, right? Where was all this stuff? Group labels. Wave row offsets. 80. Oh, 1? 8001. Hang on. 1, 2, 3. That's weird. That ain't right. Hang on. Out? No, what is the macro for that? It is out, okay. Offset D. Okay, so 0, then 128. Oh, yeah, okay. Yeah, I am. That is correct. I forgot they're backwards. So 0080 is 128. 0100 is 256. So on and so forth. Okay. Yeah, we're good. It's good. So I'm going to be taking these and adding them to the source address. So ASLI once. Yeah. SLA. Clear carry and load up. The low byte, and I'm just going to use the low byte. Just straight up use it, aren't I? And I'll be adding the high byte. Yeah. Add X. Store that into waves CHR dest. So I don't need to actually do this right here. And then we're gonna load up that +1, and we are going to clear the carry and add that to waves CHR dest +1. Oops. Add the offset for the start, the row start. Row is high byte, column is low byte. Yeah. Oh, I need to actually store that into that. I need to do the same thing over here as well. So I haven't touched X, so I can still use X. Because we already transferred that stuff over. So we're gonna take that and just add that again to the source. This is the source stuff. This time we're adding both bytes to the source. Clear carry, add carry to waves CHR source, and store that into waves chr source. Not, well, yeah, actually, yeah. And we don't clear the carry in case of rollover. Right? Yeah. Yeah. So this should have, yeah, should have the correct addresses. In theory. All right. And then down here, we're going to check for nm odd branch equal over there. Okay, so that's taking care of the, no, actually, we're not doing that there. No. Not doing that there. Instead, we are going to, over here, game. Increment the current row. Compare that to 8. This resets it. Okay. Oops, I don't need to say there. Okay. Animod, that changes in the NMI. Okay. So this is no longer using address pointer 0. Instead, that is going to be using waves chr source. I'm gonna bit 2000 there. Load up waves chr dest +1. Store that into 2006, and then the other half of that address. One frame is 64 tiles. Yes. Yeah, it's big. So it's 8 by 8. So one frame is 64 tiles. All right. Latest current row does not need to happen here. Should not happen there. Okay, so that takes out a little of the calculation stuff from the this here unrolled row waves draw row. Or not draw, it's right row. Can you do rows to increment by a frame? I mean, whereabouts? What do you mean by increment by a frame? Like for what? Let's see what this does. I don't remember what this will do. I'm not sure what I'm expecting. Oh, well, that's different. All right, well, that's only writing those two things right there. All right, well. Oh, because I never call the setup. I never call the prep. That's going to happen at the end of a game frame. Prep CHR right. That's different indeed, yeah, right? So not all these values are garbage values. I was looking for incrementing the CHR source address. Well, I don't know. Maybe. But I'm using lookup table for it anyway. Over here, the raw offsets. So, did I already symbol this? Yeah, it did. Got that. All right, let's see what happens. Wow, that broke different. All right. Okay, let's grab the watch window again. Get rid of that, and oops, and that one, and that one, that one, that one, that one, that one. Get rid of all these, a lot of these. All right, so I want waves CHR source. That ain't right. Waves CHR dest. That looks more correct. What else? Waves anim weight waves anim odd waves current row. All right. If you use lookup table, do you need to add the current? Do you need to add the current address? Yes. Yeah. So I look up an offset and I add that to both of the source and destination, actually. Ow. All right. So let's see what's going on here. So you know what? Let's close out of that. No, I don't need to save those changes. Go ahead and reset that. What is this? Go to location. Nothing. All right. First one is the prep. Good. All right. First one's prep. So what happens? Load up the animod is equal. Well, it's top really, but whatever. That doesn't matter. Let's write it on the bottom. Fine. Current row, ASLA added a bunch. It's nothing. Load up the offsets. Okay, so this is the first one. That's correct. C8E5. That is. Oh, that's the offsets. Clear carry. Add zeros to everything. Okay. And we're doing the same thing for. Huh? 1 and 2. Why did I do that? Source address to start. Okay, well, that's wrong. Oh, because do that. Okay. All right, that's better. 8001. Okay. And then load, then add 0 to that essentially. Increment the current row. Okay. So we've got 8001 as a source, 1C100 as the destination. That should work. You know what? Let me actually hang on. Let me at the top of everything, I'm not going to load up this stuff. No, this stuff. Not doing that. So I can see it actually draw, right? Yeah. All right. Switch the page. So it's going to be writing on the bottom. Yes, it is. Okay. So the first one works. The second one should start here at 1C80. Still on the bottom. Okay. Second row, row ID 1. ASLA it with the offsets. This time it's 80. 0. Okay. So the CHR destination is 1C80, which is correct. And then this guy is 8081. That also sounds correct. Amazon, how you doing? What are you trying to do? What's the debugger's name? The debugger is part of my emulator. The second link there, messin'. And I am working on animating a background on the NES in assembly. All right. And then I implement the row. And go to there. Okay, and it's actually drawn there. That's good. That's correct. Ah! Nope. Okay. All right, so it's switched pattern tables too early. So it needs to be 1, 2, 3, 4. This is like 8. Why is it switching so early? I'm switching way too early. Let's I'll do that. Anim weight. Oh, because the first one is 4. That's why. That's why. It was a bad bad value to start with. Go over here. Okay. All right, yeah. So the anim weight now is 8. That's good. 1, 2, 3, 4, 5, 6, 7. Okay, now this one's the last one on this side. 8. Okay. Then it starts right into the top. Then it should write at the bottom, but it writes the same thing. Well, okay, so we're not doing terrible. We're not doing terrible. It's just writing the same data. Okay, so now I need to increment the frames. It's getting there, yeah. And I'm odd. Okay, so this here. Jump anim done. Right there. And this is going to increment the current frame. Load up waves current frame. Compare that to $15. Branch carry clear. Otherwise, we're loading up 0 and storing that into waves current frame. Yeah. Okay. And now I need to take the frame into account. Let's search our data. So that means I need to. So that's what. So then this needs to change. So this needs to change to a different lookup. Right? Probably. This here. Then I need to look up here and have that as a start data instead of that. Okay. Load up. Or no. We are. Do I have the? No. I need to load up. Let's grab this. Put that over there before I break things. Current frame, ASL A, transfer that to X. Let's transfer it to Y actually. And then we're going to load up wave frames at Y, store that into waves CHR source. Y plus 1, or that plus 1. Okay. Oh yeah, waveframe. I need to actually define that. Wave frames undefined. Oh, because that's like data wave frames, isn't it? Yeah, data wave frames. Low byte will be the same. Will it? It will. I'm loading it anyway, whatever. And there's still that like one tile that's all scuffed up. Oh! It works! It actually works! Holy crap! All right. Now I need to figure out what's going on with that. That I like that. I like that a lot. I like that a lot. It is alive, and that works surprisingly well. Surprisingly well. Wow. All right. How's my timing doing? Oh, it's cutting it close, but it's working. It's working. That's actually pretty satisfying. That's nice. Yeah, I blew out an attribute somewhere. I don't know where or why. Let's actually have a look at that. Let's CPU memory. 2, 3. C0. It's this guy here. Header breakpoint on. Right. Reload that. A is 1. What happened? Why is A1 here? Oh wait! Oh, that one went too far. Wait a minute. This guy's screwing up. Thank you for the follow. Appreciate that. Okay, yeah. So that guy's screwing up. Clear. Okay. 23 DF. X is 1 and yeah. So that's where I was. That's where that's screwing up. It's on the draw right. What is this? This is like the unrolled draw walls. All right, I'll come back to that. I'll fix that in a bit. First, I need to commit this before I break it. Git add make file game.asm main.asm images waves.sprite and I also want the wave bitmaps as well. All right. Add animated background. Added a 15 frame background animation. A 15 frame 8 by 8 tile background animation. This uses both pattern tables. And swaps the background between them every 8 frames. The tiles on the unused pattern table are updated during these 8 frames. That's actually pretty satisfying. On that note, I'm gonna go to the bathroom real quick, so I'll be right back. Don't go anywhere. Welcome back, Jojo. Welcome back. I got something working when you were away. All right, now to fix that weird little thing over there. So that's the walls bugging out. Yeah, so let's figure out why that's doing that. So that's in the draw wall routine. Where is it? Addresses and things. Game wall, right? Oh, right. Draw, is it? Draw current map. Where is the walls? So what did I fix? A lot. Yeah, I got where is it? I got animations working. Wood. Oh, it's it's flashing between the two because it's, yeah. All right, that's pretty funny looking. Yeah, I got CHR animations working. Thank you for the host, Jojo. Appreciate that. I said about 2 minutes of AWS and got distracted. Good job. But But yeah, so you can see it's updating the CHR data, like 8 tiles at a time. So it's updating one of them and then updating the other one. So for 8 frames, it updates these tiles. And then after that, after it updates, it switches to them. And then for 8 more frames, it updates the other tiles. And switches to them back and forth. That way you don't have to keep changing where it points to in the CHR. Yeah, so that way I can update the CHR, and I don't have to touch the name tables at all. Because this is only like 120. This is only a kilobyte of data that I'm changing. If I were to do it here, I'd be changing a lot more than just a kilobyte. Because there's like 3 and almost 4 rows of this frame, of this image that's tiled, that's repeated, and there's 4 columns of it. So that's a lot of data to be writing to the name tables. So writing to them to the CHR instead is a lot less data to write. What is the difference between the top and the bottom of the CHR viewer? They are the different pattern tables. So you can point the background to one of them and the sprites to the other one. What I'm doing is I'm pointing the sprites to, I forget which one of them, I think the bottom one. And then I'm switching which one the background is pointing to every 8 frames. And I am updating the other name table, the one that's not in view, or the other pattern table that is not in view currently. I'm updating that one with the new tile data during the NMI. So it cuts it really close though. So all that red down there, that's me writing to the PPU, the CHR RAM, and I've got like about 2 scan lines at the end of that I the game draw walls, okay, that I have to spare. Game. So if I break there, I'm on scan line 259. 259. What's my do I have scroll scan line cycles? Cycle 235 of scan line 259. So I'm like way over here somewhere. No way over here somewhere. Someone spinning balls of flame then? Yeah, pretty much. But that said, these are just animation frames. That's all they are. They're like static images that that I've got animated as a frame, right? Right. I've got animated. So I can change these out for any 15 images. As long as it repeats nicely, it tiles nicely. It could be anything on there. Yeah, I could have other animations already loaded in. I mean, I have how many more banks do I have free? Yes, look at all that free space I have. 1, 2, 3, 4, 5, 6, 7, 8. No, I could have 9 more animations. No problem. Animation for secrets. What? But yeah, I can have 9 more animations of the same length and size, without worrying about running out of space, which is nice. So yeah, I could probably have 11 if I move the map data into the first bank. I don't think I want to do that. Like that one Japanese poker game. But yeah, I'm liking how it's looking so far. I really that is pretty satisfying. I think I do want to change the colors though. Like I had them up. I had the other colors up before. But this guy was going to be like that color, and then this one was going to be in that color, and like that color, right? Yeah, like that looks better as water, right? I could do like a purpley one, right? Yeah, so I mean, you know. Whoop. Washed out. Bright white tops. I don't think that looks too good. I don't know. What I could also do is like I could cut down on the number of colors in the background, make it like 3 colors instead of 4, just so I have an extra color to work with. And palette animations, I could do that too. It'd be a uniform animation for everything though. It wouldn't be like it wouldn't be all that complex. It'd be like a uniform animation, and that would affect like everything really. That would affect all the background. So I'm using the same attribute data for everything right now. I think it worse. But let's take care of that background thing. No. So draw walls. There it is. Okay. So it's the right wall that goes haywire. This guy here. I just pointed 0. So let's see what that starts at. Oops, down in A. Okay. Oh, that's the clear, yeah. And then this guy, so we're gonna go back to disassembly view. Where are we? Way up here. All right, so our address. $3F. That ain't right, is it? So address pointer 0. Yeah, so 23F. That is not right. It needs to be 1F. Okay. Oh, here it is. No, make. Well, I can remove the breakpoints. There we go. That's better. There we go. Game ASM and commit fix wall drawing on main board. Fixed the right wall start address so it doesn't write to the attribute table. There we go. And that's for the background stuff. Where's my palettes? Game. Let's change those to. Sort of here. Oh, doesn't matter. colors. 01, 11, and 21. 01, 11, and 21. That's better. Yeah. Yeah. Oh, you know what? Let's also I commented about right here. So we're gonna load the same frame on both of them for the start, just so there isn't any jankiness at the very beginning of that. Right, and so it actually shows the background for the 8 frames. It's a still background, but that's fine. That's fine. But yeah, progress. We made some significant progress tonight so far. Let's go ahead and commit this as well. Well. Okay. Commit. So this is change BG colors to blue. Draw initial frames or BG frames. Change the BG color palette to use blue colors instead of green. Sleepy Mia!
Hacker Man, he's the most powerful hacker of all time.
How you doing? Is it gonna...
It's Sorte Paggers.
Paggers. How you doing, Mia? Welcome. For 13 months in a row. Thank you so much for that. I really do appreciate it. But welcome. How you doing? What else did I do? Right. Draw the first frame on both pattern tables to start. You're good. That's good. It's good to hear. I am making some pretty decent progress tonight. I got the background moving, so that's nice. But yeah, I don't know. I need to figure out what to work on next now. Yeah, I was actually pretty surprised that like that animated first try. I expected it to like break halfway through the animation, but it actually worked first time. The first time I tried the whole animation, I do. I don't know if I'm sold yet on like the water wavy effect, but now that I've got it working, I can change it a lot easier. I just need to change like the actual animation over here to be literally whatever I want it to be. Yeah, and I can just like compile it and it'll do it differently. It'll you know, put it in there without me having to write any code, which is nice. And let me actually, I haven't done this in a while. Let me copy this and let's see if my hardware wants to cooperate tonight. I need my where's my adapter? Actually, there it is. Found it. We're good. Found it. But yeah. So how was Cosmo's birthday today, Mia? Did that go well? I was there for most of it, for most of that stream. But dev, paste it over there. Yes, replace. Cosmo's very happy. That's good to hear. And there we go, like that. Put this in over here, and let's see if my hardware wants to cooperate tonight. All right. Where's my controller? There. Way over here. Oh. Oh, dear. Hang on. Hang on. I'm going to make a mess, aren't I? Okay. That actually doesn't look too bad, even with the dithering. I don't think. Please cooperate. It's cooperating. This is looking good so far. Yeah, I blew it. Yeah, I'm blued. How's that song go again? But yeah, that's looking pretty decent. Let's reset on that real quick. Let's get one of the child boards on it. So let's go over to board 7. All right. So it's drawing stuff when it shouldn't be drawing things. All right. How am I gonna do this one? Well. GG, all right. Oh no! Oh no! Oh, I broke. I broke. All right. Well then. No, it doesn't. It doesn't. Let's see what's going on with that. I probably do actually. Yeah, I probably do. Want a different. A different child background. 7 game. Oh, it's writing different CHR data, isn't it? Wait a minute. The data there is correct. Oh, because it doesn't. Well, I mean that's weird and wonky. Okay, so the background data, or okay, something went wrong, and I started overwriting some stuff up here. What is that? It broke. It broke again. Yeah. All right. Well, let's restart, and then over here. No, that's well neat, but not the one I wanted. Actually, let's go to draw child map. Yeah. Try again. Oh, try again. Come on. Really? I want to get to like one of the bits in the center there. Really? Really? Okay. You know, almost working. I'm almost getting there. I missed. There we go. Okay. All right. Switch to disassembly over here. Over that. Because it shouldn't be like rewritten any of that crap. You know? Okay. Starting that stuff. That's correct. Different name table routine? It shouldn't. Okay, so here, at this point, we are correct. Everything is correct. None of the other tiles are overwritten. That's good. Reset ball. Reload the NMI stuff. NMI pointer. Okay. We're gonna break on that one. What is this one? Is this one the one I want? Well, that's the prep, and let's get rid of that one. And I also want the right row. That, what is this? Get rid of that too. Okay. All right, so for the animation prep, we'll just go to the right row. Yeah, so it's scrolled weird, which is why it shows that. Not that one. Let's get the watch window. This guy. All right. So the source is 8981. Oh, wait a minute. That's like in the middle of an animation, isn't it? Well, whatever. Should be fine. That shouldn't actually matter, really. Because it should just pick up where it left off. OD80. Where's that? Okay. Oh, there it is. And it's going wonky. All right, that's the one that does it. All right. That's pretty far, actually. Because it's got vertical right on, doesn't it? It has vertical right on, so it's incremented by 32 each time. Yeah. So I want the other right. Is that control? Yeah. This guy here. 2000, I need to write... I need to write 0 there. Load up... Actually, I can just load up... What is it? CPU control, because that has it set correctly. Yeah. That's not what I wanted to do. Make. Okay. Oh, I need to undo those breakpoints. Goes. Oh, and I wanted a different map too. No. Okay. That's better. So now it doesn't break everything. Yeah, so I'll probably want a different background on these guys. I might just use a different animation for that, and the same code, essentially. But we'll see. We'll see. I'm not drawing the stuff on the background, but still, it ain't though, Mia. The blue is actually the walls. So that's what it bounces off of. I haven't gotten to the point of figuring out what I want the walls to look like. So, yeah. I also need to fix the down boost as well. Yeah. Because if you're traveling down a little bit, ever so slightly, and you hit the boost, it boosts you down, which ain't supposed to happen. Yeah. But all right, that's a little fix anyway. We can go ahead and add. All right, fix vertical right before writing to CHR. Set the PPU address increment to 1 before drawing the wave animation to the PPU. All right. All right. And let's go ahead and actually draw that on the background as well. On the child board. It'll probably be a different animation or something later on. But I can at least put it there, you know? Where am I? Draw a child map. This guy here. So first we're going to fill clear ID. Where's the walls? Where does it draw the walls? Over there. Okay. Yes, we're gonna do that way up here. JSR to something. Wave draw background. So now the child board should have that background on it as well. Good. I will be changing this, I think, eventually, but before that, I think I need to figure out what I'm doing with the background of the play area. Because while I'm drawing the map, I'm either drawing something, right, a brick, or I'm drawing nothing. I'm drawing the black area. But I have to put a value there in order to increment the address automatically, right? Nothing needs to skip. Yeah. So I don't know if I just want a like a background pattern there. Increment the address and branch. I'm not sure what you mean by that. I'm not sure what you're getting at. Okay, so I need to figure out what I want to do with the background of the actual table itself. If I want to have the animation on that background after a tile clears, I'm going to need some sort of lookup table for the tile IDs given a screen address, or screen X and Y anyway, which probably shouldn't be too hard if I write up a lookup table for that. I need to figure out the math though first. So that's possible. That's certainly possible, I guess. But yeah, then the initial drawing of the board, I'd have to draw whatever is there essentially, or I'd have to skip the bricks that aren't there. So I'd be keeping track of the PPU address like manually. Can I load the PPU address actually? Like, is that something I can read from the? No. Well, yes. How do I am? Dealer has the access to the other buses. CPU writes to VRAM to the pair of registers on the CPU. Yeah. First has the address. VP for RAM. After reading the status to reset the latch, write the 16-bit address of VRAM you want to access here. Up by first, for example. Okay. Access to preview scroll and address during the screen refresh produces interesting raster effects. Certain position of each scan link. We said that possibly. Yeah, okay. But can I read the address there? So my idea is, like, when I encounter a blank tile, I would read the current address of the PPU and store that, and then count the number of blank tiles I have, and then increment the PPU address that many times and rewrite it. That's my idea anyway. I don't know if it'll work. It might. I don't know. I'll have to try that out later, I think. But yeah. Yeah, because otherwise I would need a lookup table of the, well, I'd still need a lookup table of things. Index already in a Y, right? Probably. I would still need a lookup table though for destroying the brick, so that'd probably just be easier. I just use the same lookup table for both of them, so I wouldn't bother reading the address from the PPU. Instead of it's 0, I'd look up the appropriate tile in that lookup table for writing the background animation tile. Oh. Yeah, I think I'd do it that way instead. Because then I'd be reusing the same data and code. So, well, a lot of the same code anyway. For the initial drawing of the map and the removing of tiles. Yeah. So I'll figure that stuff off. Figure out that stuff off screen. I think off stream. Yeah. Draw background animation on child boards. 8x8 tiles? Yes, the animation is 8x8 tiles. Correct. I'm sure there's a fairly simple math for it. I just don't know what it is, what it would be off the top of my head. Maybe being bad at math and all, but column and 7, possibly, and row and 7, maybe. Drop that in Discord if you could. I'll have a look at it later. Anyway, on that note, I think I'm gonna call it for tonight. I'm getting a little hungry, even though I did eat like just before stream. I'm getting hungry again. And I got a lot done today. I didn't think that would be that easy, honestly. Like that right there, that worked in a single try. Like I thought of this almost 4 hours ago. And I was able to implement it in roughly that amount of time. That's surprising to me. Xtremi, how you doing? Why an assembly? So I'm learning. I'm writing stuff in assembly so I can learn how NES games are made, so I can reverse engineer other NES games to use them in tool-assisted speedruns. To use those like exploits in tool-assisted speedruns and all that kind of stuff. That's the gist of it. But how you doing? Welcome. Yeah. Oh, something somewhat related. So I started. I could do that. Oh, I'll do that off stream. Did some assembly last year. It's hard. Did you x86 assembly or like ARM? I'm not doing either one of those. I'm doing 6502 assembly, which is significantly simpler. So this right here is my are all of the official instructions, and a lot of them are like mirrors of each other. You had to play with the register. I don't know. Was it like 8-bit assembly or was it ARM assembly or something like that? I'm just curious. But yes, this is all I have. These are all the instructions I have to work with. I don't have things like multiply and divide. I have to do that myself. I did that stuff manually or have a lookup table or something like that. Linux school. All right. It was probably x86 then. Which is significantly more complex than what I'm working with. Yeah, if I can English correctly. But yeah. So I'm writing stuff for the NES, and it does actually work on real hardware as well. Okay, I fixed that. If I reset that real quick, and then just hit start again. Some assembly is harder than others. Yes, most of the basic difficulty is getting the mindset down. I agree. Yes, most of the difficulty is getting just the mindset down of writing it. But yeah, this is what I did tonight. I got like a wavy water animation working it on stream. I did the actual graphic animation itself off stream, like 10 minutes before stream, honestly. But yeah, I'm happy with the result so far. I'm happy with it. Worked well. Anyway, I think we're gonna go say hi to somebody. So don't go anywhere quite yet. Let's go see what we can say hi. I'll be back on Saturday. There is a movie night on Saturday night. I think we decided on watching Shrek. Not the Japanese dub like I wanted, but we're watching Shrek and the terrible Ghost in the Shell live action movie. So I'm looking forward to that. Looking forward to that one. That's gonna be a fun one. That's gonna be a good one, I think. Oh, here we go. This could work. I haven't rated this guy in a long while, I don't think. I think I've rated him before. If you forget I had an original, I don't know about that. So this guy is going through some tasks, actually. This is, yeah. Copy that. Put it over here. Okay, okay, I need to put raid and then the name, not just the name. Okay, so this guy goes through tasks and verifies tool-assisted speedruns. Looks like he's doing Mega Man right now. Yeah, taskbot test for Mega Man 2. So yeah, he watching the stuff that he's done for GDQ is actually was actually a big motivator for what I'm doing here. So please come with me to say hi. I will see you guys on Saturday. I'll see you then.